Hi everyone. Okay, today we're learning about maximum and minimum problems. Okay, and after curve sketching, this should seem pretty intuitive. So we learned in our last unit on curve sketching that local maximums and minimums occur where f prime at x equals 0. We also learned that for a maximum, if f double prime at x is decreasing or is negative, we guaranteed that we have a maximum, whereas if f prime at x equals 0 and f double prime at x is greater than 0 because the slope of the tangents are increasing, then we're guaranteed to have a minimum. But when we're testing a function over endpoints and we're trying to see the maximum or minimum value in just an interval, a given interval, so say from A to B, then the maximum of the function could be at a maximum, like where the tangent is horizontal, or it could be at an endpoint, like over here in this diagram. Okay, so in this case, the overall maximum between A and B, between when x equals A and B, would be at an endpoint, and same with the minimum here. Okay, and in this case, in our middle diagram, the overall minimum is at an endpoint, but the overall maximum just on that interval is at a maximum value. Okay, so basically the algorithm for doing these problems is just going to be find all values of x that satisfy f prime at x equals 0 and test them in f at x. Okay, so we're going to check the local max and minimums and what their y values are, so how high up or down they are. Then we're going to find the value of f at a and f at b. Those are testing the endpoints. And from that, we're going to determine the overall minimum value, the smallest value, y value, and the overall maximum value, which is the largest y value, and answer any questions involved. Okay, so here's our first question. Find the extreme values of each function over each interval. Okay, so here's our interval. If we want to test the endpoints right away, we can. So if we test the endpoints, we would be finding f at -1, f at -1 would be -2 times -1 cubed plus 9 times -1 squared plus 4, which would be, that's going to be +2 in the end, plus 9 is 11, plus 4 is 15. And then we'll also find f at 5, which is going to be -2 times 5 cubed plus 9 times 5 squared plus 4, which I'll do on my calculator here. So -2 times 125 plus 9 times 25 plus 4 is -21. Okay, so now we're going to see where the tangent's horizontal. So first we're going to find f prime at x, which is -6x squared plus 18x. And we want to put it in simplified factored form if we can, because it's easiest to see where our tangent can be horizontal. So actually no, -6x is common here. And then we would have x minus 3 set equal to 0. So our tangent is horizontal when x equals 0 and when x equals 3. And so now we're going to test these x values into our function. So we're going to find f at 0, which is 4, and f at 3, which is -2 times 3 cubed plus 9 times 3 squared plus 4, which is going to give us -54 plus 81 plus 4, 31. It's going to be -27 times 2 plus 81 plus 4. Yep, 31. Yeah. Okay. So now we're looking for the overall maximum, which is here when x is 3 y is 31, and our overall minimum, it would be at this endpoint. So find the extreme values of each function over the interval. So therefore, the max is 31 when x equals 3, and the min is negative 21 when x equals 5. Okay, so there's our extreme values. Okay, next question. So we weren't given the endpoints here, so my bad. We'll make them up. Then we'll do from, I don't know, -2 to 5, let's say. So we'll test our endpoints first. So we'll find f at -2. It's going to be -2 squared minus 2 over -2, which is 4, plus 1, which is 5. And then we'll also find f at 5, which is 5 squared minus 2/5, 25 minus 2/5, which is 24 3/5, or 123/5. Okay, now before we can take the derivative here, we want to rewrite f at x as x squared minus 2x to the -1. Okay, that's just f at x. Now we're going to take the derivative. So that's going to be 2x plus 2x to the -2. Set f prime at x equal to 0. So we have 2x plus 2 over x squared. So if we subtract the 2x to the other side, multiply both sides by x squared, we're going to get -2x cubed equals 2, or that x cubed equals -1, and the cube root of -1 is -1. So that's our only place where the tangent's horizontal. So we're going to test it. F at -1, this should be. F at -1 is -1 squared minus 2 over -1, which is 1 plus 2, which is 3. So in this case, 123 over 5 is 24.6. So our overall minimum is here at -1, and our overall maximum is at 5. So therefore, max is 24.6 when x equals 5, and min is 3 when x equals -1. Okay, here's a word problem type of question. The predicted population in millions of a small country is modeled by this function. Population at x is x squared over 400 minus x over 10 plus 5, where x is the number of years since 2001, and x belongs to the closed interval 0 to 30. So we've got our endpoints right away. So we can test our endpoints. So we need to find p at 0. So I'm just subbing 0 in here and I get 5, but it says the population is in millions, so this really represents 5 million people. And then we'll find p at 30, which is going to be 30 squared over 400 minus 30 over 10 plus 5. Remember, our answer's in millions. And I got 402 million. I don't know, that doesn't sound right to me. 900 divided by 400, 2.25, minus 3 plus 5, just 4.25. Okay, so 4.25 million. So there's our endpoints. So now we want to derive P at x. So P prime at x is going to be, so that's 2 over 400 x to the 1 minus 1/10. Okay, so we're going to set that equal to 0, and that'll be 1 over 200 x minus 1/10. Add 1/10 to both sides. Multiply both sides by 200. So x is going to be 20. Okay, so now we're going to find P at 20. That's the only place where we have a horizontal tangent. So now we're going to test it. P at 20, 20 squared over 400 minus 20 over 10 plus 5. So that's going to be 1 minus 2 plus 5, 4 million. And we read the question, determine in which year the minimum population occurs. So our minimum population is 4 million, and it occurs 20 years after 2001. So 2001 plus 20 is 2021. So therefore, min population occurs in 2021. So always make sure you answer the question they ask you. So sometimes they'll ask you for the X value like they did in this case. Sometimes they'll ask you for the max or minimum or the Y value. Just read the question carefully. Okay, and our last question. A flu epidemic breaks out in Mathville. The fraction of the population that is infected at time t in weeks is given by this function. Determine the maximum fraction of the population that is infected over the first 10 weeks. So we've got our endpoints, so we might as well test them. So f at 0 is 0, because 64 times 0 is 0. F at 10 is 64 times 10 over 18 cubed, which is 64 times 10 divided by 18 to the power of 3, 0.1097. And that number is a fraction of the population, so I guess I should have left it in fraction form. All right, so instead I'll do 640 over, figure out what 18 cubed is. 5,832, and then see if I can reduce that down. So I think I can divide top and bottom by 8. $80. And I don't think that reduces anymore. So that's our fraction at 10 weeks. And then we have to do our derivative. So this one's going to require us to do the quotient rule. So our first function is 64t, and its derivative is 64. And then our second one is 8 plus t to the power of 3. And its derivative would be 3 times 8 plus t squared times 1, which is just 3 times 8 plus t squared. Okay, so then f prime at t, quotient rule, derivative of the first times the second, minus, so I can multiply these monomials together, 64 times 3, 192 t, 8 plus t all squared, all over 8 plus t all cubed squared. Okay, and that's just using the quotient rule. So now I'm going to factor it, put it in simplified factored form. So okay, 64 goes right into 192, so that's handy. So 64, and then I have 8 plus t to the power of 2, and then open up my bracket, so I'm common factoring out each chunk here. So that's going to give me 8 plus t minus, so 3t, all over 8 plus t, all to the power of 6. And then these 2 and these 6 can be divided because they have the same base. So I've got f prime at t equals 64 times 8 plus t to the negative 4 times 8 minus 2t. Set f prime at x equal to 0. Let's sort out what's going to be in the top and the bottom. And then the nice thing here is that with the denominator, if I just multiply both sides by 8 plus t to the 4th, 0 times anything is still 0. So those go, and those multiply to give me 0. So I'm going to end up with a really nice, easy equation to solve, because now I can divide both sides by 64, which will give me 0 equals 8 minus 2t. Add 2t to both sides. Divide by 2, and we've got our t value is 4 when the slope of the tangent is 0. And now we're going to find f at 4 and then compare it. So it's going to be 64 times 4 over 8 plus 4 is 12 cubed. So let's see what we get when we do that. 64 times 4, 256 over 12 to the power of 3. 1728. See if we can divide by, I know we can divide by 64 probably. Yep. So 4 over 27. So, and we're looking for the maximum fraction. So 4 over 27, if we do this in our calculator, is 0.1481, and 80 over 729 is 0.109. So the biggest fraction is 4/27. So determine the maximum fraction of the population. So therefore, max fraction of population infected in the first 10 weeks is 4/27 of the population. Okay, so then there's some practice questions for you to try, and they should have the same type of look as these. Okay, so you have the same things. You always test your endpoints. Find where the slope of the tangent is 0, test those places or that place, and then answer the question that they talk about. Okay, thank you.